Hello everyone, let us see next example of complex number. If omega or w is 7th root of unity, then we have to prove that this sum yes is equal to 1 plus omega raised to n plus omega raised to 2n plus omega raised to 3n up to omega raised to 6n is equal to 7 when n is multiple of 7 and is equal to 0. That means sum is equal to 0. Otherwise means if it is not multiple of 7. Okay, let us start with, we have to find out 7th root of unity. Let x is the 7th root of unity, then x is equal to 1 raised to 1 upon 7 means 7th root of unity means 1. Now as usual, by procedure, put 1 as equal to cos 0 plus I sin 0 raised to 1 by 7. Again add 2k pi to the angle and take 1 upon 7 inside the angle using De Moivre's theorem as usual. And k we want 7 roots, that's why k should be 7, that is from 0 1 to up to 6. One number less than this number is 6. Okay, total 6 roots are there. Let us start putting values of k is equal to 0. We get x 1. First root is cos 0 plus I sin 0, that is 1. Where cos 0 is 1, sin 0 is 0. Put x k is equal to 1, we get x2 is equal to cos 2 pi by 7 plus I sin 2 pi by 7. Call it as omega or w. Then put x is equal, k is equal to 2, we get x3 is equal to cos 4 pi by 7 plus I sin 4 pi by 7. Now again using De Moivre's theorem, split this 4 as 2 into 2 and take that 2 in on the indice. We get this 2 pi by 7 raised to this bracket raised to 2. Again by De Moivre's theorem, if we get 2 inside, we get the same 4 pi by 7. Now again this is omega, that's why the third root will be omega raised to 2, that is omega square. Now put k is equal to 3, we get fourth root as 4 cos 3 to the 6 pi by 7 plus I sin 6 pi by 7. Again make this 6 split 6 into 6 as 3 into 2 and take this 3 on the indice using De Moivre's theorem. We get 3 to the again 6 equal, these 2's are equal using De Moivre's, and this again becomes omega and this is omega cube. Like this method, go on putting values of k and we get this 7 root as omega raised to 6. Okay, we have this 7 root of unity. Now let us start with the first. When n is multiple of 7, we have to show that this sum is equal to 7. Okay, if n is not multiple, let us start with if n is not multiple of 7, then s is equal to 1 plus omega raised to n plus this sum. Consider this sum, then split this 2 into n as omega raised to n raised to square. Again indice raised to indice means 2 into n to n. This again to omega raised to n raised to 3. Again this is omega raised to n raised to 4 plus omega raised to n raised to 5 and last plus omega raised to n raised to 6. Now if you observe, this is a geometric progression series with the first term as 1 and common ratio after second term is omega raised to n. Then addition of such 7, these are total 7 terms including 1 2 3 4 5 6 7. Okay, therefore the series will be a into this first term into 1 minus r raised to 7. R is a common ratio and a is a first term, that's why this equal to 1 minus, this is 1, first term is 1 minus r raised to n is 1 minus omega raised to n is a ratio raised to number of terms, that is 7, divided by 1 minus r, that is 1 minus omega raised to n. This is a geometric progression series formula. Now again reverse these indices, omega raised to n raised to 7 is again omega raised to 7 raised to n, both are same. And we know omega raised to 7, omega is 7th root of unity, is one of the 7th root of unity. That's why omega raised to 7 value is 1. That's why it's become 1 minus 1 raised to 1, and 1 minus 1 is 0. Because 1 minus omega raised to n is not equal, is omega is not multiple of 7. That's why 1 minus omega raised to n is not equal to 0. In this first case, if omega or n is not multiple of 7, then it becomes 0 if it is multiple of 7. We are considering n is not multiple of 7. That's why this subtraction is not 0. Denominator is not 0, but numerator is 0. That's why total answer is 0 for this sum if n is not multiple of 7. Okay. Now consider second case. If n is multiple of 7, then n can be written as 7 into k. It is multiple of 7. That's why where k is a integer, any integer, positive or negative. Now consider this sum. S is equal to this, as usual, sum. Again split this sum as put the value of n as 7k here everywhere. Okay, keep these numbers as it is. Instead of n we have to put just 7k everywhere. Okay, now take this omega raised to 7 and rest of the numbers on indices. We get omega raised to 7 raised to k here, where k is integer. Omega raised to 7 raised to this 2k, omega raised to 7 raised to this 3k, omega raised to 7 this raised to 4k, up to omega raised to 7 raised to 6k. Now again omega raised to 7 value is 1, because omega is a 7th root of unity. That's why everywhere 1 raised to k, everywhere omega raised to 7 value becomes 1, and k is an integer. Therefore 1 raised to k, 1 raised to 2k, 3k, each value is 1. That's why 1 plus 1 plus 1 plus 1 up to 6 terms are there, including this 7 terms are there. The answer for this is 7. Okay, if it is multiple of 7, then answer for this sum is 7. And if it is not multiple of 7, then answer for this is 0, which we have proved earlier. Now let us see next example. Find all values of 1 plus I raised to 1 by 3 and represent these values on Arrangement diagram. Means find all values of any complex number, means we have to find out all roots of this complex number. How many roots are there? Raised to 1 by 3 means 3 roots are there of this complex number. We have to find out those 3 roots, and we have to show those roots, those are complex numbers, in simply Arrangement diagram. Let us start with this complex number. Let x is equal to 1 plus I raised to 1 by 3. If you want to use de Moivre's theorem, we have to convert this Cartesian form into polar form. Therefore let r is equal to under root of x square plus y square. X is 1, y is 1, 1 plus 1, that's a root 2. R value is root 2, and x value is 1, y value is 1, and 1 lies in the first quadrant. Therefore theta is tan inverse y upon x, that is tan inverse 1 upon 1, that is tan inverse 1. Value of tan inverse 1 is pi by 4. On calculator you can calculate this value. Therefore above 1 plus I can be written in the polar form as r into cos theta plus I sin theta, which is root 2 into cos pi by 4 plus I sin pi by 4. Once we reduce this Cartesian form into polar form, we can use the de Moivre's theorem and root raised to 1 by 3 here. Therefore x is equal to, take 1 by 3 on both sides. We get x raised to 1 by 3 is 1 plus I raised to 1 by 3 is 2 root 2, then into this number raised to 1 by 3. Take 1 by 3 inside. To this number we get 2 raised to this 1 by 2, and this is 1 by 3. Cos pi by 4, I sin pi by 4 raised to 1 by 3. Again start the root procedure here. Add 2k pi to this angle before taking 1 by 3 inside, and k start from 3 roots are there total, that is 0, 1, 2. Now take this k inside. Before that take pi common from the root. Root 2 raised to this 1 by 2 into 1 by 3 is 1 by 6. this constant as it is everywhere. Now cross multiply this, we get x is equal to x raised to this 1 by 3, 2 raised to 1 by 6 as it is. Cos of cross multiplying, we get 8k plus 1 by 4, 1 by 4 into pi plus I sine same angle raised to 1 by 3. Now take this 1 by 3 inside using De Moivre's theorem. We get cos of 8k plus 1 by 12 pi plus I sine 8k plus 1 by 12 into pi. This as it is 2 raised to 1 by 6, where k start from 0, 1, 2. Now go on putting values of 0 k here. K is equal to first root is x1 0 for k is equal to 0. We get 2 raised to 1 by 6 cos pi by 12 plus I sine pi by 12. Put k is equal to 1. We get x2 as 2 raised to 1 by 6 as it is, cos 9 pi by 12 plus I sine 9 pi by 12. Put k is equal to 2. We get x3 as cos 17 pi by 12 plus I sine 17 pi by 12. Now these are the all values of this number. Now second question is, we have to represent these values in Argand diagram. Argand diagram means we have to put these complex numbers into xy plane, where r value is 2 raised to 1 by 6. That is 2 raised to 1 by 6 is a radius of the center of the circle. 2 raised to 1 by 6, calculate on the calculator, or just take the this much of radius as 2 raised to 1 by 6. Okay, this is just a Argand diagram. And theta we have to put first on pi by 12. This is a pi by 12 first value, first number. 9 pi by 12 is a second point here. This same radius is same and angles are one difference. We have to take the calculate the angle here. Pi by 12 is 180 divided by 12, that is 15. Therefore calculate okay. This is the circle. Draw the circle of 2 raised to 1 by 6 radius everywhere, and this is the first point with pi by 12 angle, that is 15 degree here. First point is here. Now second radius is same, 9 pi by 12 is angle here, P2. And third point in the Argand diagram is 17 pi by 12. 17 pi by 12, if you calculate on calculator, we get to 55. That is somewhere here. These are the 3 points with radius same, 2 raised to 1 by 6, and angles are, this one is pi by 12, 15. This is 9 pi by 12. This is 17 pi by 12. This is called the Argand diagram of the roots of the given point. Now let us, here the diagram has some mistakes. This is point first, this is the third point, P3. Okay, now let us start with same type of question. Find all values of 1 by 2 plus root 3 by 2 I raised to 3 by 4 here. 3 by 4, where 3 is the indice positive power of this complex number, and 1 by 4 is the root, and it indicates the root of this complex number. 1 by 4 means there are total 4 roots, and we have to find out those 4 roots and show that their continued product is unity. Means we have to multiply all those 4 roots and we have to show that the value is unity. Unity means 1. Let us start with the point. Let x is equal to half plus root 3 by 2 I. To use De Moivre's theorem, we have to convert this Cartesian form into polar form. For that we need r under root of x square plus y square. X value is 1 by 2 square, that is 1 by 4, plus y value is root 3 by 2, that is square is 3 by 4. Answer is 4 by 4, that is 1. Now point this x and y value is positive, that means this point lies in the first quadrant. For first quadrant we know theta is tan inverse y upon x, that is tan inverse this y upon x, 2 gets cancelled. Tan inverse root 3 is pi by 3. You can calculate on calculator, we get this pi by 3 60 we get on calculator, that means multiply by pi by 180 we get pi upon 3 in radiant form. Now rewrite this number as in polar form as r into cos theta plus I sin theta. This is r, that is 1 cos pi by 3 plus I sin pi by 3. Now let us take 3 by 4 on the both side. In dice we get this number raised to 3 by 2 is equal to this polar form raised to 3 by 4. Now before adding 2k pi to the angle, take first this indice, positive indice 3 inside the bracket using De Moivre's theorem. We get only this, we have to take 3 inside because this 3 is not indicating root. This 1 by 4 indicates root, but therefore apart from 1 by 4 we have to take this number inside to the bracket using De Moivre's theorem. Now after taking 3 inside we get 3 gets cancelled, cos pi plus I sin pi raised to 1 by 4. Now it becomes the 1 by 4 means 4 roots we have to find out. Then add 2k pi this 2k pi to this angle pi. Before taking 1 by 4 inside we get cos of 2k pi plus I sin same angle raised to 1 by 4. Now take pi common and take outside the angle and take 1 by 4 inside using De Moivre's theorem. We get cos of 2k plus 1 pi by 4 plus I sin 2k plus 1 pi by 4, where we have 4 roots. That's why k start from 0, 1, 2 up to one number less than this number, that is 3. Now go on putting the value of k. We get the 4 root. Put k is equal to 0 here. We get first root x1 cos of pi by 4 plus I sin pi by 4. K is equal to 1. We get x2 cos 3 pi by 4 plus I sin 3 by 4. Similarly, put k is equal to 2, we get this third root, and put k is equal to 3, we get this fourth root. In this way we have find this 4 root of this complex number. Now the second question is show that their continued product, means we have to take the product of this 4 root. Therefore continued product is equal to x1 into x2 into x3 into x4. I put these values here, we get the x1 into x2 into x3 into x4. Now this is multiplication of all brackets complex numbers, and all the middle sign of this bracket is plus. That's why we have to use the formula, that is cos of addition of all the angles plus I sin same angle addition of all these angles. This is a formula for multiplication of all brackets where middle sign is same for all the terms. Now go on adding this, denominator is same, that's why we have to add numerator. We get 16 pi by 4 plus I sin same angle 16 pi by 4. Now 4 is 16, therefore cos of 4 pi plus I sin 4 pi. Now calculate on calculator. Cos of 4 pi is 1, sin of 4 into pi means 180 degree, is 0. We can calculate like this. Cos 4 by 4 into 180. Answer is this is in radian. We have to first convert into degree. Okay. Now this is cos 4 by 4 into 180. Answer is 1. Okay. And sine of 4 pi, just sine of this 4 pi is equal to 0. Therefore answer is 1 plus 0 is 1. Therefore continued product of this 4 roots r is 1. Now let us see next example. Find all values of, means we have to find out roots of all well, all the roots of this complex number I raised to 1 by 4. Now let us consider I is equal to, by using note, we have to write I is equal to cos pi by 2 plus I sin pi by 2, because we know cos pi by 2 is 0, sin pi by 2 is 1, I is equal to I value. Now take, this is a polar form of this I. Now take 1 by 4 on both sides, we get I raised to 1 by 4 is equal to this bracket raised to 1 by 4. Now add pi by 2k pi to this angle, we get 2k pi plus pi by 2 plus I sin this same angle raised to 1 by 4. Now take out pi common, we get 2k plus 1 by 4 or 1 by 2 pi plus I sin 2k plus 1 by 2 into pi. Now cross multiply, we get 4k plus 1 by 2 pi plus I sin 4k plus 1 by 2 into pi. Now take 4 inside to this angle, we get cos of 4k plus 1 upon 8 pi plus I sin 4k plus 1 upon 8 pi. Total 4 roots are there, therefore k values start from 0, 1, 2, 3. Now go on putting values of k here, we get put k is equal to first 0, we get first root as cos of this 0 pi by 8 plus I sin pi by 8. Put k is equal to 1, we get this second root. Put k is equal to 2, we get this third root. And now third root, this question is only find out the roots, therefore from the half of the half roots are the angle, we have to split the angle as addition of the earlier angles. Like for example, put if k put values of k is equal to 2 here, we get third root as cos 9 pi by 8 plus I sin 9 pi by 8, and 9 pi by 8 can be split into pi plus pi by 8. Cross multiplying, we get 8 pi plus pi, that is 9 pi by 8. This angle is the earlier any one of the angle, that is first angle pi by 8. And we know cos of pi plus theta is minus cos theta, and sine of minus theta, pi plus theta is minus sine theta. Therefore take minus common, we get minus of cos pi plus I sin pi by 8, which is the first root. This is just a negative of first root. Now last, put k is equal to 3, we get fourth root as cos of 3 4 is a 12 plus 1, that is 13 pi by 8 plus I sin 13 pi by 8. Now split this 13 pi by 8 as pi plus 5 pi by 8. 5 pi by 8 is the angle of second root. You can take this reference as the addition of angles. Therefore cross multiplying, we get a plus 5, that is 13 pi by 8. Now again put the value of cos pi plus theta is minus cos theta, sin of pi plus theta is minus sin theta. Take minus common, we get cos of minus cos of 5 pi by 8 plus I sin 5 pi by 8, which is the second root. This is just a negative of the second root. Let us have some homeworks. These are all our homeworks for you. Find all values of these roots. One Cartesian form, 1 plus I raised to 2 by 3 minus I raised to 1 by 3 minus 1 raised to 1 by 5 and 1 minus root 3 I raised to 1 by 5, 1 by 4. You have to just find out all the roots. Here total 3 roots are there, here also 3 roots, here 5 roots, and here total 4 roots are there. Okay, let us see the next example. Prove that nth root of unity form a series in a geometric progression. We have to find out nth root of unity, and we have to show that those roots form the geometric progression. That means it has first number, first term, and it has common ratio after second term. And also show that the sum of this n root is 0 and their product is minus 1 raised to n minus 1. Okay, let us start with the, let x is equal to nth root of unity. Therefore x is equal to 1 raised to 1 by n. Now put 1 is equal to, we have to find out root, that way put 1 is equal to cos 0 plus I sin 0 raised to 1 by n as it is. Now add 2k pi to the angle, we get cos 2k pi plus I sin 2k pi raised to 1 by n. Now take this 1 by n inside to the angle, we get cos 2k pi by n plus I sin 2k pi by n. Here total n roots are there, therefore k start from 0, 1, 2 up to one number less than n, that is n minus 1. Total number are n. Now we have to go on putting value of k. We get k is equal to 0, we get x1 is equal to cos 0 plus I sin 0, that is 1. Cos 0 is 1, sin 0 is 0, therefore it is answer is 1. Now put k is equal to 1, we get x2 is equal to 2 pi by n plus I sin 2 pi by n, call it as alpha. Put k is equal to 2, we get x3 as cos 4 pi by n plus I sin 4 pi by n. Now split this 4 as 2 into 2 and take that 2 on the indice. We get this same root raised to 2. 2 to the again 4, same root. That's why this again alpha raised to 2. We already seen this example. Now put k is equal to 3, we get x4, 4th root as cos 6 pi by n plus I sin 6 pi by n. Again split this 6 as 3 into 2. Therefore cos 2 pi by n plus I sin 2 pi by n raised to 3. By using De Moivre's theorem, we can take any numbers into the indice and take any number from the indice to the inside angle. And this is again alpha, therefore it becomes alpha case to 3. Now this is the and so on. We have the last root, that is k value is n minus 1. We get xn is equal to cos 2 pi by n plus I sin 2 pi by n raised to, here if k is equal to 3, here 3 is there, that's why for k is equal to n minus 1, here n minus 1. The answer is, this is again alpha raised to n minus 1. If you observe these roots, 1 alpha, alpha square, alpha cube, alpha raised to 4 up to alpha raised to n minus 1, we have this n roots, and this is has a first term 1 and common ratio as alpha. That's why this is a arithmetic progression. This series is a arithmetic progression. Now we have to show, the first question is done. Now second question is we have to show the sum is 0 and product is this. Now start with sum. Therefore is sum is equal to 1 plus roots, sum of the roots, that is 1 plus alpha, alpha square, alpha cube raised to alpha raised to n minus 1. Now this is geometric progression. Its value is a into bracket 1 minus r raised to n upon 1 minus r, where a is first term, r is common ratio, and n is number of total number of terms. Therefore a is 1 here, first term, r is alpha, and total number of terms is here n minus 1, and including this one, total n roots are there, therefore raised to n as it is. Now put the value of alpha here, we get this term as it is, alpha is this. Okay, now take this n inside to this angle by using De Moivre's theorem. We get n gets cancelled. Answer is 1 minus cos 2 pi plus I sin 2 pi, and we know cos 2 pi is 1, sin 2 pi is 0. The numerator of this term is 1 minus 1. Denominator you can put this alpha as it is, no matter. 1 minus 1 is 0, therefore numerator is 0, therefore denominator total term is 0. Therefore sum of this all roots of unity, n root of unity is 0. Now take product. Product is equal to 1 into alpha square into alpha cube raised to alpha raised to n. Base is same, that's why take addition of all the indices, we get alpha raised to 1 plus 2 plus 3 up to n minus 1. Now we know this is the n is a natural number, therefore addition of first n natural number we know is n into n plus 1 by 2. Addition of the n minus 1 natural numbers, replace just n by n minus 1. We get n minus 1 here and n minus 1 here, plus 1 as it is divided by 2. Therefore here n into n minus 1 divided by 2. Now put this value of alpha. Alpha is our this root. Therefore it becomes cos of 2 pi by n plus I sin 2 pi by n raised to this n into n minus 1 by 2. Now take this indice inside to this angle. We get n gets cancelled, 2 gets cancelled, n minus 1 into pi plus I sin n into n minus 1 raised to into pi. And we know cos of n minus 1 into pi value is minus 1 raised to n minus 1. And sine of n minus 1 into pi value is always 0. This is the this is the formula, that cos of n pi is minus 1 raised to n. Therefore cos of n minus 1 pi becomes minus 1 raised to n minus 1. And sin any number, natural number, minus into pi becomes 0. Therefore answer is minus 1 raised to n minus 1. The product of n root of unity is minus 1 raised to n minus 1, and sum is 0.